Hi guys, last lecture for graph theory and Euler circuits. Okay, I'm going to click on the graph theory and Euler circuits notes, which will open them up. I've got them here and scroll down to where we stopped last time, where it says to complete practice 1C, which really should be E, I think. A, B, C, D, E. Yeah. Well, let's look. Yep, should be, should have said 1E. What are you going to do? All right, let's finish this up. Let's take a look at how to Eulerize a graph. What is that even? Why would we do that? Well, we do it because most real-life routing problems don't have Euler circuits. You're gonna have vertices of odd degree, but we still want to find the most efficient route. And this means there needs to be the least amount of duplication or repeating paths. So to Eulerize a graph, it's a process that we use to find the most efficient route, and we eliminate vertices of odd degree by duplicating edges of the original graph. So an optimal Eulerization has the fewest possible duplicate edges. Now, a semi-Eulerization is used if we don't need to start and stop at the same place. So we're finding an Euler path as opposed to an Euler circuit. So we're allowed two odd vertices. So when you draw the graph, I suggest kind of using an open dot for every vertex, and then for every even vertex, fill in the dot. And as you make your vertices even, fill in the dots until you have all closed dots for a circuit or two open for a path. So if you look here, I colored in some dots and I can see that I have even, 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 and then I have these that are odd. So I could duplicate from here to here, here to here, here to here, and here to here. So what I've done is I've duplicated 4 edges. Now, I could have, instead of duplicating those, I could have duplicated maybe here and here, because what's important is that the vertex that you're duplicating to must remain even at the end of it all. So here, this one is now 1, 2, 3, 4, 5, 6, 7, 8. This vertex is now degree 8, but it's still even. Now this is bad. This right here, yeah, don't do this. Why? We went off-roading. We created paths or edges where edges didn't exist, and that's bad. Do not create routes that don't exist. Okay, so looking here, I have these that are even, and each of these here has degree 3. So a simple fix is to duplicate 2 edges. This is good. This is bad, guys. Do not create routes that don't exist. All right. So to find a semi-Eulerization starting at A and ending at B, I was able to leave 2 odd vertices, A and B. So to make A odd when it was even, I duplicated an edge over. And then I duplicated there to make this one even, and here to make this one even. These were already even. So now I'm able to travel this as an Euler, as a semi-Euler path. So is an Euler circuit possible here? Well, before I duplicated, no, because this one had degree 3. So I had odd vertices. So by duplicating 4 edges, I was able to create a graph where all vertices are now even. In your booklet, if you have it, there's 2 problems on the next page for you to try on your own. And we're done. Let's take a look at 1F, which is practice set 4. So here you're looking for optimal Eulerizations and semi-Eulerizations. Pretty straightforward. And then practice set 5. Again, we're looking at optimal Eulerizations and semi-Eulerizations. Now, y'all, you don't have to print these. If you want, you can draw them freehand or on graph paper, either one, okay? Now, when you're done with all of that, you're going to click on 1H, which is the summative assessment. And here, you're going to find some stuff that you can do that's just going to show us what you've learned in this unit. Remember, this is not for a letter grade. This is, I've done this unit, I've put in this time, I want to show my teacher what I've learned. You can complete it, and there is a Dropbox in Schoology where you can turn it in. And then I will be absolutely happy to give you some written feedback on it. All right, guys, until next time, see you after spring break.